Okay, this is for the screw group. So we are going to talk a little bit about screws. Here's one. This is a clamp. But first let's do a little diagram of it. So if we look up here, we have a diagram of a screw, and I have this lever on the top. Well, you notice this has a lever on the top, that little bar. But even if it didn't, just the fact that the screw itself has thickness means that there's a little bit of a lever there. So anyway, this has that lever on the top that we're concerned about, and it also has a spacing between those spirals. So basically, how many times, how many turns do you have to do to make it move a certain distance? The bigger P is, so the spirals are spaced out more, that means one revolution makes you go a lot higher. If they're really, really close together, one revolution goes not as far. So since we're really concerned about revolutions, we end up having to think about circles a little bit, which is the reason when you do the ideal mechanical advantage, you have 2 pi comes into there. So this is theoretically the mechanical advantage that I have if I use a machine like this. Now that said, there's friction, things don't work perfectly, so to find out the actual mechanical advantage, we need to do an experiment. Here's how we can do one. We have, let's see if you can see this without me dropping my computer. We got a clamp, we have a dual range force sensor, and I have this set to 50 newtons. What I'm going to do is stick in this clamp. Let me say, actually I want it to be turned a little bit more like that. Here we go. So I have the, there we go, the sensor inside the clamp, and the sensor is hooked up to a lab quest, which is telling me how much compression I'm going to get on it. So if I were to squeeze this, it goes up and reads the force on there. So what I could also do though is pull this clamp, turn it, and measure how much force is being exerted. Now right now it says there's a whole bunch, but I'm not actually pulling it. That's because it's stuck. The friction's holding it in place. So let's get it loosey-goosey again. Alright, and this time, instead of pulling it with my finger, I could pull it with a spring scale. It also tells me a force. So if you look on it, there's a measure of how many newtons. So if I yank on it a little bit, whoop, that little plunger goes down, tells me how hard I'm pulling. So if I combine pulling on the lever with the spring scale and measuring this, I can measure my applied force here and my actual force there. And that, combined with our ideal mechanical advantage, should give us a sense of how efficient this actually is. Hope this helps. Bye now.